had our previous session on Saturday, so it's just 1 day break that we were able to get. And now today we are again having the session. So as I told you, this week we are having sessions on Monday, Wednesday, and Saturday, right? So one of the most important things that I want all of you guys to kind of take into consideration over here is that you have to understand that initial few modules that were there in your course curriculum, they were theoretical, right? So this is your coursework. I've already shared it with you. And now the most important thing over here is that we have to get started. So I got started with basics of Python in the last session, if you remember. So we got started with what are the different variables, what are the different data types, and what is if statement, if else statement, if else statement, right? What is for loop, what is while loop, what is nested loop, what are some of the basic inbuilt functions in Python. So in the previous session, what I tried to do is that in the previous session, I tried my level best to make sure that you are getting started with Python, point number one. And in today's session, what I would be aiming for is that you guys will get an idea about two important libraries. One is Numpy, another one is Pandas. We have a lot of time. By the way, we have 2 sessions for this because up till this moment, we have just completed 3 sessions, which is 6 hours, right? So we have 6 separate hours for Numpy and Pandas along with this part. But I don't think we would be requiring 6 hours. I think we would be requiring 4 hours, and it's better to have a lead of 2 hours so that we can use this lead of 2 hours later on when you want to do doubt clarification or when you actually require it. We will then spend it. So today's session, we will try to start with NumPy, complete NumPy, and then the next part is that we will try to aim for Pandas. All right, we will start for Pandas, but obviously Pandas is a really big library and I cannot complete everything that is there in Pandas in just one session. All right, so what I'm kind of planning to do over here is that let's try to complete NumPys today, start with Pandas today, and complete Pandas on Wednesday. So this is what I'm aiming for. Correct. Another thing over here is that NumPy, Pandas, this is totally live coding based. Like there is no theory in these libraries. Like there is some theoretical background, but it's not like that I would be coming up with the PPT and we would be discussing that. No, it's not going to happen like that. Why? Because it is not that what is that library about, it's basically about what are the functions that are present in the libraries which will help you to ease out the life. Okay, so the first thing over here is NumPy, right? Let's discuss NumPy. Let's start with NumPy. So NumPy stands for numerical Python, right? The full form of NumPy is numerical Python. Now, what is basically happening over here is that in numerical Python, you guys are kind of expected to get an idea about the fact that whatever are the numerical calculations that a data scientist, a deep learning engineer, a machine learning engineer, they are doing, it is done with the help of pre-written inbuilt functions that are present in NumPy and Matplotlib. Right, it is basically done with the help of pre-written inbuilt functions that are present in NumPy and Pandas library. That to NumPy. So basically, whatever is the numerical calculation that you want to do, like if you want to find the mean value, if you want to find the median value, if you want to find the average, if you want to find the mode, if you want to find the standard deviation, if you want to find the variance, if you want to get an idea about outliers, everything can be effectively completed with the help of pre-written inbuilt functions that are present in NumPy. Everything. Please remember this. Everything can be effectively completed with the help of NumPy libraries and everything. Now, the thing over here that I want you to understand is that NumPy library has a data structure of its own, which is called as ND array, which is basically a matrix format, right? In 11th and 12th, or even in engineering first year, you might have studied about matrices. So ND array stands for n-dimensional NumPy array, and you can have a NumPy array of any shape, any size, any dimension, which we will discuss in today's session. And this NumPy arrays, they are having two advantages. First is they are fast as compared to Python list. They are very fast as compared to Python list. And second is that they are requiring less memory as compared to Python list. We will verify this also in the live coding session. We will try to verify this particular section also. So basically what is happening is, let me revise all of the things for you. Numpy is a library in Python, right? It stands for numerical Python, point number one. And basically what is happening is that majority of the numerical calculations that you would be expected to do as a data scientist or as a machine learning engineer, you would be doing that over in Python with the help of the functions that are available over here. Point number one. Point number two is that NumPy library has a data structure of its own, which is called as ND array, meaning n-dimensional NumPy array. What is n? N is a variable number. You can decide the number of dimensions according to your own wish, according to your own need and everything. Okay. Third point that I want all of you guys to understand is that we will try to see the inbuilt functions that are present in NumPy and Pandas, and we will try to get an idea about it. Like there are so many inbuilt functions. You can create an array of zeros, array of ones. There is arange. So learning NumPy is majoritarily about understanding that what are the functions that are present in NumPy and how to use these functions when required. It's majoritarily about that, right? So let's open up a new Jupyter notebook, right? And let's start code. So basically what we are kind of planning to do over here is that we will write session 2 over here. We will add the cells over here. And guys, please remember that all of my sessions are live coding based, right? That is why we are spending so much amount of time. Otherwise, we would have simply given you the coded files and we would have said that please go through the files later on. Okay, we could have literally done that. But the reason why we are not doing it because our sessions are live coding based. We want all of our learners to code along with us. Right? Are you getting my point, guys? What I'm trying to say? So this is like one of the really important portions that I want all of you guys to be in sync with. Okay, so let us get started. After this particular portion is done, let us get started with NumPy and Pandas and let us try to see what are the things that we can do over here. Okay, so first of all, you will have to install NumPy library, right? It is done with the help of exclamatory mark pip install NumPy. And as soon as you run this code in my laptop, it will show requirement already satisfied. Why do you think, guys, everybody is it showing requirement already satisfied? Can you tell me? Guys, anyone? Because NumPy is already available in my laptop. I use this laptop every day for coding for my freelancing projects, right? But in your laptop, if you're using it for the first time, it will download the setup of NumPy and it will install NumPy over there, right? And next thing is you have to import NumPy. So import NumPy and the aliasing name that is used in industry is NP, right? Now, after that, let us try to create an array, creating an array, which is the data structure of NumPy library. NP underscore weight, it is equal to NP dot array. Okay, and here let's have 45, 56, 78, 87, 98. And what we are having is print array NP underscore weight and also print data type of that variable. It is type of NP underscore weight. So now after this is done, what is basically happening over here is that you will get an idea or you will get an overview about this particular portion, right? So it is a NumPy array of class. See, the object is of class NumPy ND array, meaning n-dimensional NumPy array. Everybody meaning n-dimensional NumPy array. I didn't have to attend yesterday's, sir. I didn't get your point. The previous session was on Saturday, and if by any chance you were not able to attend Saturday's session, then it will definitely have a negative impact because everything is kind of connected as I told you, right? So whatever you are planning to do, everything over here is kind of connected. So no problem. Try to see the recorded sessions and you can get started with it. Today we are starting with a really new topic, which is NumPy. By the way, this NumPy arrays are used for storing the data almost in every deep learning algorithm. Recording session is on YouTube and I will also ask the course coordinators to give it to you. Right? Don't worry about it. I will ask the coordinators to give it to you. Don't worry. So please type it quickly, guys, and then let's try to move ahead with the next part. Yes, Praveen, tell me what's your question. You have raised your hand. So guys, please quickly type this in your laptop and you can see that np.array is the function that will help you to convert a given object into NumPy array. NumPy arrays are homogeneous, meaning that all the elements that are present in the NumPy array, they are of same data type, right? 30 seconds on this, guys, and then we will have to move forward with the next part. Now, after this particular portion is done, can I move forward, guys, with the next part, everybody? So this is one of the very basic things. You have to install NumPy in your laptop. You have to import NumPy as NP. Why only as NP? Because that is the industry standard, and I am sincerely hoping that all of you guys should follow what is the industry standard, right? Now, after this particular portion is done, let us try to move ahead with the next part or the next concept over here. Shivani, same done. Let us try to move ahead with the next part. So in the next part, what we are basically doing over here is that always remember these two things. NumPy array versus Python list. As I told you, it is always done right over here. fast and less memory. So let's try to verify it. And the comparison is always done based on two things. The first is computational time. Second is memory consumption. And we will verify both of these two things, by the way. One more thing, NumPy arrays are homogeneous, meaning that all the elements, all the elements of a NumPy array are of same types. Okay, now let's try to move ahead. After this is done, let's try to move ahead with the time comparison. I am using new laptop. Could you please share the link to download Jupyter Notebook? Sorry to disturb you. Absolutely no problem. My suggestion is download Anaconda Navigator from this website. And in Anaconda Navigator, there is a tool called as Jupyter Notebook. So you can use Jupyter Notebook from there. Right. So time comparison is the next big thing. You have import time, right? And size is equal to 10 lakhs. And then you are having declaring the list. Okay. L1 is equal to range size, right? L2 is equal to type this code, guys, everybody. So now after this is done, it's np.arange, and instead of np.arange, let's have np.array size, and similarly with E2. So what I'm doing is that I'm creating NumPy array and and two Python lists of same size, right? And then we have list start is equal to time.time, res is equal to x plus y for x comma y in z L1 comma L2. Print Python list took time.time minus start into 1000 milliseconds, because whatever is the time that they are giving, it's in microseconds. And let's try to do it for array. Start is equal to again time.time. Okay, but result is equal to a1 plus a2, and here we have NumPy arrays took this much amount of time. So time.time always gives the current time. Start is recording the starting time, and the difference between them is the guys. Everybody, guys, difference between them is guys. Everybody, what is the difference between them? Time.time minus start. It is the time that it takes to complete the given part. Exactly. Time taken for computation, Vishnu. Correct. Yes. So, and one more thing, we will try to have np dot round this comma 2, right? np dot round this comma 2. So you will get the values rounded off till two decimal places. Now, depending on your individual laptop, the processing speed and everything, the time may vary in your laptop and in my laptop. It's not going to be exactly same. But in general, you can see that Python list took 7 times more time than NumPy array. So let's say that you have written a program. Let's say hypothetically that you guys have written a program which takes 1 day using NumPy array. So if you use Python list, it will take 7 days, 7 times, 7 to 8 times, which is not at all a good idea, right? So that is like one of the really interesting things, one of the really interesting portions that we have to kind of move ahead with, right? Take your time, go through this, and then we will try to see what better we can do about this. Everybody, guys, take your time, see this code, and this code is basically something which proves that NumPy arrays are significantly faster as compared to Python list. This is a code which proves that, right? So take your time, everybody, guys, go through this and let me know if I can help you in any of the portions. So you have 2 minutes to type this code in your laptop. Then we will try to write the next block of code over here. So the most important thing which I want all of you guys to take into consideration is basically the fact that all of these things kind of play like a very pivotal role. Okay. And you are expected to be that person who takes these things or these points into considerations and moves ahead with it. Now, after this is done, please scroll down a little, and this is the code. If I scroll down a little, this is the code, right? So one of the most important things or one of the most important points that you need to consider is that when you are working with very complex times and when you are working with very complex algorithms which are going to consume a huge amount of time at that particular point of time, these things will definitely make a difference. Okay. So guys, are you done with this particular part? Have you written this code in your laptop? Have you executed this code? Right? So Shruti is saying yes, Shivani is saying, what does time.time return? Time.time basically returns the current time when it is executed. At the point when it is executed, then it returns the correct time, current time, right? And it definitely plays like a very pivotal, very important role over here. Need a minute, Vishnu. I totally understand. You take your time and let me know once it is done so that we can move ahead with the next part. It's not in IST, it's in microseconds. When you multiply it by 1000, it's in milliseconds. Correct, Vishnu is done. Let's get started with the next part. So now time-wise, you know that NumPy arrays are way faster. Let's try to do it memory comparison, right? Let's try to do memory comparison, which is the second point, memory comparison. So what is happening over here is you have to import sys, then you have declaring a list s is equal to range of 1 lakh or maybe 10 lakhs, printing the size. So print size of each element of the list in bytes. It is sys dot get size of s, and size of list in bytes is this into length of s. Then the next part over here is that numpy array what is it? It is s dot, no, one more thing, declaring a numpy array b is equal to np dot arange, and what is happening over here is that it is d dot item size into d dot size. So you can see 48 divided by 4, right? So Python list, it took 12 times more space, right? Python list took 12 times more space than NumPy arrays to store the same data. Correct? What is zip doing in the above code? Zip is like first element of L1 would be added with first element of L2. Second element of L1 would be added with second element of L2. Like you have a zip for jackets. So the consecutive thread of left and the right part is overlapped on each other. It's a function. Yes, check, it's a function, right? So consecutive elements of L1 and L2, only they are added, not all of them, right? So that is basically something which I wanted all of you guys to understand. Take your time, go through this, write this code in your laptop. And by the way, once this is done, then you let me know. We can then kind of try to move ahead with the next part. So now the most important part is that if you have an option which is having less amount of space, or I mean, which is consuming less amount of space and which is consuming less amount of time, so why will you not use that one? Obviously, you will use that one, correct? So that is basically something which you need to understand. Now, after this is thus get size of it's one and the same thing. It's just that these are the two different functions. Now, we are absolutely correct. Get size of or item size. It's kind of doing the same thing over here, but they are different functions that will help you to do these things. Now, after this is done, let us try to move ahead with the next functions over here. This is done, right? So the next part over here that I want all of you to understand is matrix of zeros and ones. So there are functions over here that can help you to create a matrix of a desired shape filled with zeros, and you will say where it is used. It is used in deep learning to initialize a matrix of a particular shape, right? So print zero matrix of shape percentage s is percentage s percentage mat underscore zeros dot shape comma mat underscore zeros. And similarly, you can initialize a matrix of ones, right? Which is done with the help of this, right? So this is something that I want you to understand. 3 by 5, 4 by 2, right? So you yourself can see that how these things are kind of present over here. And the most important part is that these things really help you to get the matrix in the desired shape and the desired format that you want. Take your time for this. Let me know if I can help you with anything, guys. And then we will move ahead with the next part. So, you know the applications, you know the process, right? I hope you are comfortable with this, like how to create an array of zeros and ones. That's the first thing that I'm hoping that you should be clear with. And the second thing that I'm hoping you guys should be clear with is basically the fact that you should know the arrays of zeros and ones that you need to move ahead with, right? Now, let's say that you don't want zeros and ones. Like it's a very rare thing that you will want exactly zero, exactly one. It's a very rare thing. Let's say that you want to fill it with a particular value according to your own wish. For that also, we have a function called as np.full, which is helping you to create an array according to your own wish. You can fill it with whatever value you want. So np.full is the function. You write this in your laptop and then we will move ahead with how we need to kind of tackle that idea. So now after this is done, let's try to move ahead with matrix with a particular value. So mat underscore full is equal to np dot full shape is equal to 5 comma 3 fill underscore value is equal to 5. Okay. And then here we have full matrix is this. So I'm filling it with the value 5. So you can observe that of a particular shape 5 by 3 matrix I am able to retrieve over here. Right? Take your time, go through this and let me know if I can help you with anything, guys. So basically, you now know how to have an array of a particular shape, how to have an array of a particular size, and how to take this one particular point into consideration. Now, after this is done, let us try to move ahead with another interesting thing called as help function. So let's say that there are so many functions, you don't know the syntax of a particular function, just type that function help and the name of the function in that np.full. You will get the complete official documentation with regards to np.full, what is the syntax. You will also get the practical things over here. Okay. And that is how it should move ahead, right? So any function, now you guys would be learning so many different functions, so many different things over here. Any different function that you guys see, it is completely possible for all of you guys to move ahead with this. Completely possible. Now, after you guys are aware of this particular thing, right? Let us try to move ahead with the next portion. Okay. Read that np.full documentation, by the way, if you want to, because I personally think that will really help you in getting an idea. You will feel more confident because as a newcomer, you may feel that okay, there are so many functions, so many syntaxes to learn, and how am I able to get an idea, or how will I get the overview about the point, right? You will feel like that. But the point over here is that it is not practically possible that you all always understand that until and unless you have spent like decent 2-3 years into this particular field. And for a newcomer, that is why I always recommend that it's a really good idea if you use this np.full, get idea about the syntaxes and then move ahead. Correct? So you know np.1s, np.0s, and similarly there is another function that is kind of present over here, and the name of that another function is np.random. Actually, there is a module that is kind of present over here. So let me tell you how that module works. So array of random samples, and that too standard normal samples. Mat3 is equal to np.random.random random normal 3, 4. Print generated matrix mat3. So basically what is happening over here is that the values that you get in your laptop and the values that I will get in my laptop, right? They would be different. Reason being that it is randomly generated, right? Standard normal. Then for uniform distribution, right? Mat2 is equal to, let's have 5, 3 mat2, and uniform distribution means that the values in the range of 0 to 1, right? 0 included, 1 not included. Please remember this. So it can have 0 as the value, but not 1, right? So take your time for this as well. And let me know if I can help you with anything. So these functions that are kind of present over here, they definitely play like a very pivotal role in making you aware of the topics that needs to be completed, right? So np.random.random, np.random.rand, these two are the important functions. Now, after this is done, let us try to move ahead and let us try to pay attention for creating array of random integers, right? So here we have creating an array of random integers that are present over here. So mat1 is equal to np.random.randint. Low value is 0, high value is 1, and size of the matrix is equal to 3 by 3, right? And then you print the generated matrix, which is mat1, right? High value is 100, let's say. Always remember, high value is never included, but low value is may be included. Getting my point, guys, everybody? So what is happening is that 100 will never come. 0 may come, but 100 will never come. Right? So low means that it should have at least that value. High means that up till that value we need a matrix. Correct? And size basically is the size of the matrix that we need to work around with. So all of these methods are basically something which will come in very handy when we are trying to move ahead with the next part. Take your time, write the code for last two portions, and let me know once it is done so that we can move ahead with the next part. One more minute, guys. Try to implement it quickly so that we can move ahead with the next part or next logic. One of the learner is saying finish, sir. Okay, let's wait for the other learners to complete it. Then Ryle is also saying done. Okay, very good. So now after this is done, let's try to focus more on the other section, guys. Right? So after this is done, random module is done, finished. Okay. So let's try to move ahead with np.arange in detail. We have already used np.arange, but let's explore it in detail, getting the sequence of the data. Right? So basically, np.arange, right? Start value is 5, stop value is, let's say, 50. Step size that you take is 5, and the data type needs to be integer. So basically, again, stop value is not included. Please remember this. So it will start from 5 and it will go till 50 with a step size of 5, but it will not include 50. Right? The most important concept is it will not include 50. Everybody, guys, please try to take this into consideration. So now after this is done, let us take a break of what you can say 10 minutes and let's resume at 2013. Right? Take a break of 10 minutes and we will resume at 2013. Everybody, guys, 10 minutes break. Thank you. So let us get started, guys, with the session over here, right? So now after this is done, what I wanted is that let's take some examples of arange, right? Let's take some examples of arange function. So v1 is equal to np dot arange, okay, and 5, right? So default starting is 0 and step size is 1. Print generated matrix or generated array. It's v1. v2 is equal to np dot arange 2 to 5. Here you can see that the default step size is 1. Correct? And v3 is equal to np dot arange 0, comma, minus 10, comma, minus 2, and generated array is v3. So this is basically something which is telling you the array, right? Or giving you the array. So it will start from 0, it will go till minus 10, but not minus 10 since last value is not included. And from that, you can get an idea that how the matrices are created or arrays are created over here, right? So take your time, go through this, and let us know if you want help in any of the sections, guys. So arange function has a lot of default values. It's just the stopping value which is not having any default value. Other than that, all the other values are having default entries, right? So this plays like a very pivotal role. Okay, this is definitely playing a very pivotal role over here. Correct? Take your time, go through this, and let's move ahead with the next section over here. So take your time, guys. Execute this code and let me know if I can help you with anything. So everybody, guys, have you written this code in your laptop? Arange is a very important, very fruitful function which has proven to give very effective results in a lot of scenarios. So if you want to generate a sequence of numbers, then I personally think that Shruti is saying done. Okay, very good. Let us wait for a few more seconds and then we will get started. So now after this is done, why is there -10? Because I'm having that's the important part. I'm having a inverted sequence over here. So basically what we would be kind of planning to do is that we would be starting from 0, going in negative direction with a step of -2 every time. Right? With a step of -2 every time. So take your time, go through this and let me know if I can help you with anything, guys. Now, after, could you please explain the output again? Yes, I can explain the output again, Sheikh. So what is happening over here is that we are starting from 0. 0 is the starting value. We have to go till -10. Okay. And after that, we are basically expected to move ahead with the next section over here. Right? So take your time, go through this, and let us try to move ahead with the next section. Clear, Sheikh, on this? Now, can I start with the next part? So after this is done, let's try to move ahead. Why is -10 not there? -10 is not there because last value is never included. Okay. Now let us try to get started, everybody, with the attributes of an array. Okay. Let's have a is equal to np dot array 1, 2, right? 3, 4, 5, 6. And after this is done, let's try to have print shape of the array. It is a dot shape. Print number of elements in the array. Right? Number of elements in the array, it is a dot size. Then print data type of the array, not data type of variable, data type of array. Since I told you that every data type, every array is homogeneous, all the elements are of same type, right? Then number of dimensions a dot n time, and then print finally the array, which is a. So this is basically something that will help you. So a dot shape will give you the shape of the given array with which you are kind of expected to move ahead with, right? Next is a dot size will give you the total number of elements that are going to be there with which you are expected to move ahead with, right? Third thing over here that I want all of you to understand is a dot d type, which is going to give you the data type of the elements that are present over here, right? So it is int32, means that all the elements of that array are integral in nature, right? And after this is done, the next thing or the next portion that I want all of you guys to be aware of, it is basically revolving around the number of dimensions. So it is two-dimensional in nature. There are two dimensions over here that you are expected to work around with. And finally, the next part that you guys are getting over here, it is the array, right? Now, after this is done, next thing over here is, this is something which is the most basic part. Next thing over here is creating an identity matrix np.i3, and it is basically going to help you at identity matrix, right? So what is happening is that along the diagonal elements, you will get one. That is the meaning. You will get a square matrix of size 3 by 3, right? And from that, you are basically going to move ahead with this section over here. Next is another function, np.linspace, which is equally spaced elements, right? So it is np.line space. Okay. You will start from 0, you will go till 1, including 1. Okay. And you need 5 elements. So 0 is the starting number. 1 is the ending number. And including 0 and 1, we need 5 elements in total. Okay, we need 5 equally spaced elements in total. So you can see that in total there are 5 elements that we are getting which are equally spaced. Right? So these things definitely play, like, can you show the code once again? Which code you are saying? This one, 19th attributes of the array. So take your time. Yes, no problem. You take your time. So now after this is done, here is the next block of code that I want all of you guys to type. Right? And in NumPy, basically what happens is that you need to be very, very, very careful about the elements that are kind of included over here. Right? So np.I, as you guys know, it is basically going to help you in creating the arrays, correct? Which is this particular portion. And now after this is done, So like this, we will have a lot of function, lot of ways that are available over here, right, to move ahead with the next part or next scenario. So now after this is done, I have a really important function for all of you guys, which is np.reshape, right? Reshaping an array. So let's say that a particular array is in a particular shape. And if you want to reshape it, so for that we have a is equal to np.array 3 6 9 12, right? And then we have np.reshape a comma 2 comma 2. And this is basically something that needs to be done over here. So while reshaping, if you are not sure about the, okay, let's while reshaping, if you are not sure about the exact number of elements in total, you can use -1 so that the remaining number of elements are adjusted accordingly. So the thing over here is, let's have a is equal to np dot array, right? 3 6 9 12 18 24, and print then array with 3 rows, right? So it is basically np dot reshape a comma 3 comma -1. And similarly, if you want to reshape it into 3 columns, it's -1 comma 3. See, 3 rows and 3 columns, it is automatically reshaped. So we don't, let's say we don't know the number of elements over here. We don't have to calculate, just give -1. It will automatically find what is the optimal number of elements that you need to put in here, right? So this is yet another thing, and this is how you have to learn NumPy. So in NumPy, what basically happens is that you are basically expected to get an idea or get a gist about the section of how you move ahead. Correct, guys? So basically in NumPy, the gist is that there are a lot of functions, and those functions can help you to do different type of activities over here with which you need to move ahead with. So now after this is done, and once you get an idea or once you get an overview about this particular topic, Let's try to move ahead with the next section and see what better we can do. So now after this is done, the next part is that it may happen that sometimes you are expected to have the elements in a single dimension, right? So let's try to write it. Sometimes you may have an array with lot of dimensions, right? And you may be required to convert it into one dimension. So A is equal to np dot ones 2 comma 2. B is equal to A dot flatten. C is equal to A dot ravel. Print original array, right? Original, let's say shape. A dot shape. Print original array, which is A. Like that, you can have two more things: flattened shape and raveled shape. So whether you are flattening or whether you are raveling, it's converting it into one dimension, right? But there is a homework, and this is a very important question that has been asked in interviews. Find the difference between np.ravel and np.flatten. Like I can tell it right now, but I want you to research this. And this is the, and by the way, this is one of the very famous interview questions. What is the difference between np.ravel and np.flatten? It is one of the very famous questions that has been asked in different interviews, right? So take your time, go through this, and I want all of you guys to write this along with me, because reading a code, if you read a code and if you feel by reading that, okay, I'm getting coding, it's a misconception, right? So reading a code never helps you in anything, and it is only when you're practically writing the code, then you're getting an overview about the part, right? So please remember this: reading a code is never gonna help you, right? Please take this particular point very seriously into consideration. Correct, guys? Everybody, are you clear with this? So now after this is done today, your batch has received like a Really good idea, really good overview about the topic, honestly telling you. Today, luckily, your batch has received a very good session. I have taken a lot of sessions on NumPy, and this is like one of the best sessions. You got the fundamental idea about the time difference between them, right? And along with that, you also got an idea, you also got an overview about the topics, correct? So I personally felt that today we have completed a lot of points. Today we have completed a lot of portions over here. Take your time, continue this. And NumPy is a very important library, by the way, because the basics of NumPy, indexing, slicing, this is something which should be very clear in your mind. Later on, you will realize this thing when you are moving ahead. And now, after this is done, there is another important concept about finding transpose of a given matrix. Please show the output. Absolutely, this is the output, right? The original shape is 2 by 2, original array is this. Flattened shape is 4 because 4 elements are there. Flattened array is this. And now what you are doing is you are getting transpose of the matrix over here. So A is equal to np dot array, right? 1, 2, 3, right? And then there is 4, 5, 6. A is equal to np dot transpose A. Print actual array, and it is A. Then it is print shape of actual array, and it is A dot shape. Print transposed array, and print shape of transposed array. So now after this is done, you can see that 2 by 3 shape is transformed into 3 by 2 because of this transposing thing, transposing action. Correct? So type it. Finding the transpose of a given matrix is yet another thing, because when you are finding the transpose, it turns out to be really fruitful. Later on, you will get it. So what basically happens is that people are kind of taking this particular portion into consideration. So in deep learning, there is W transpose X plus C. Later on, you will come to know about it. So that W transpose X plus C is something that you need to take into consideration. So now after you guys are kind of finding the transpose of the array, transpose of the matrix over here, let us try to move ahead with with slicing, slicing the array. This is another major thing that we need to complete today. So let's have a is equal to np dot array, right? 1 comma 2, 3 comma 4, 5 comma 6, print actual array, print number of dimensions in actual array, correct? And it is a dot ending, print shape of the array, and it is a dot shape, and this is the actual array. Now let's try to slice it, right? Slicing the array. So print a square bracket 1 comma 0. 3 is printed. How? Because this starts with 0, 1, 2, and 0 and 1. So 1 comma 0 indicates at 3. That is why 3 is being extracted. So you need to pay a lot of careful attention over here so that you're not making any mistakes. Correct, guys? So slicing the array or taking this into portion will lead to a lot of things, correct? So take your time, create this array, try to see the axis, and along each axis how we are kind of trying to filter. That is one of the major portions. Now, after this is done, Dhanush Chandra is saying done. Let us move ahead with 3 dimensions, right? So, what we would be doing is again creating an array, right? And now here, guys, you need to take one point into consideration that we need to create 3D array, right? So how will you create 3D array? Everybody, guys. So what is happening is that A is equal to np.array 1, 2, 3, 1, 2, 3, 4. Then that is 5, 6, 7, 8, right? Then it is 9, 10, 11, 12. Then it is 13, 14, 15, 16, 17, 18, 19, 20. And then it is 21, 22, 23, 24. And again print the number of dimensions and print the actual array. So this is one of the most important things that you need to take into consideration. These are the actual arrays that you are going to work around with, right? And then you write it, then we will try to slice the given array. Slicing the given array. Print A1:3, comma 0:2, comma 1. So how is it giving 14 and 18? How is it giving 14 and 18? Let's try to see. So basically 1:3. What is the meaning of this? That, can anybody tell me what is the meaning of this? That this is 0, right? This is 1, this is 2, this is 3. So there are just two elements that are there in the outer. So this is one, the first one, right? This much block. Let me tell you, this much block is the index 0 block, and this much block is index 1 block. 1 colon means that only 1 will be there. So this will be removed. Now in this block, 0:2 means 0 and 1, means only this much portion will remain, right? And further, when you dig down, 1 means the first row will still get removed, right? And this is how you are getting this section. Okay. So it is basically indexing according to the elements, the indexes that are there. So let me re-explain this thing to all of you. This is standing for 0. Okay. This is standing for 1. Here it is written 1:3 means first will go out. Okay. Because it starts from 1. So this is not there. Now 0:2 means 0 and 1. Means this should be there and this should be there. This will go out. And 1 means that this is 0, this is 1, this is 2, this is 3, only 14 and 18. And this is how 14 and 18 are coming. right? So this is a conceptual, this is a really in-depth conceptual part that you need to kind of understand, right? And that is the reason I'm sharing the coding file with all of you guys. You download it, the time is almost done. And tomorrow we will start. I mean, by tomorrow, I mean next session, which is on Wednesday, we will start with pandas. Right, guys, everybody? So pandas is like one of the really interesting things that you need to take into consideration over here, and we will try to move ahead with it. Please fill the feedback form, guys. Your feedback is very important. It actually gives us an idea about what is happening in the session. And depending on the feedback that we receive, we can fine tune the sessions according to that. Right? So take your time, go through this, and let me know if I can help you with anything, guys. Everybody. Right, so it's been great mentoring all of you guys. I hope you have enjoyed today's session. This was one of the best sessions that I have mentored on to the learners about NumPy. Very in-depth, very detailed. And let's try to see what are the things that we can take into consideration after that. Okay, so thank you everybody guys. Thank you for attending the session. Please complete the feedback. Your feedback is really important for us. I have given you the file already in the global chat, right? So that you can download it. And then let's try to move ahead with the next part. Okay. Thank you everybody guys. Let us meet afterwards. Thank you. Bye. Thank you. Jay. Bye.